Okay, I just want to talk a little bit about counting. The multiplication principle is great for counting. It's not a principle, PAL, like in a high school. It's a principle, like a rule. And basically, you can use this when you have choices. So basically, when you have choices, okay, you can use this. So for example, say that I have 3 different color of pants, maybe red, blue, and white, okay? And then maybe I have 2 colors of shirts, and we don't care if we match here. So yellow and green. So we're not going to be styling here, but, or maybe we are, I don't know. And so if you have choices, you can just multiply the slots. So if I have 3 choices for pants and 2 choices for shirts, I have 6 different outfits if I mix and match, okay? And the reason the multiplication principle works for this is if you think of a tree diagram, and you can always use a tree diagram if you're stuck. I have my red pant, my blue pant, and I have my white pant, okay, or pants, whatever you say there. And then I can branch off and wear either color shirt, again, if we don't care about matching. Yellow, green, yellow, green. And the way I read this off is red pants with yellow shirt, red pants with green shirt, blue pants with yellow shirt, blue pants with green, white with yellow, and white with green. And so you notice if I read these off, right, I could do red with yellow, red with green, blue with yellow, blue with green, and white with yellow, white with green. You can see I get 6 different combinations, okay? So I get 3 choices, and each of the 3 have 2 outcomes. That gives me 6, okay? So anytime you have choices, it's multiplication principle. The other thing is if you have repetition, it is going to be the multiplication principle. So again, like say you have a 5-question multiple choice test, and say there's A, B, C, and D, okay? And you want to know how many different like combinations are there? Like how could the teacher have it be? Like A, maybe the teacher goes A, B, C, maybe D, D, C, B, A, right? Like how many answer keys could there be? Now again, I could make a tree diagram, okay, which is why the multiplication principle works. But I'm going to we have 5 questions, so I'm going to do choices. How many choices do I have? Well, when you answer question 1, you have 4 choices. It could be any of these. But notice you have repetition. On question 2, you could choose the same letter. You could go A on all of these. Repetition is allowed. So for question 3, there are 4 choices. Question 4, there are 4 choices. And question 5, there are 4 choices. So if I take 4 times 4, or I could do exponents here. So I'm going to do 4 raised to the, 5th power? All right, there are 1,024 ways that, you know, a teacher could do that. So that's why you don't just guess, right? Like if you randomly guess, you have no clue. Yeah, the probability of you guessing right is 1 chance, because only one of them is going to be the correct answer key out of 1,024 possibilities. So not a good idea. But again, it has repetition allowed, and you also have choices, but repetition is allowed. If I made a tree diagram, you could see this. Let's see, on question 1, right? So here's question 1. You could have A, B, I'm going to make it this way. I have A, B, C, D for question 1. So this is kind of my question 1. And then from each of these, I could branch out A, B, C, D for all of these. Okay, then if I have A, then I could branch out again and have 4 choices, A, B, C, D. And that could happen on all of these. And do you see how that would be the same down here? That's your what? Question 1, question 2, question 3. And then you get all of these could branch out 4 for question 4, or where am I at? Question 1, 2, 3, and 4, yeah. And then I could branch out again for question 5. So you can see how it just grows super fast. And so that's why you end up with 4 choices here. Each of those have 4 choices. 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 And that would happen for everything in this whole tree diagram. But it's much easier. Obviously, I do not want to make a tree diagram with 1,024 things. That is not going to happen. So true, false is kind of the same thing. Like if I have 20 questions that are all true, false, some people might be like, oh, I'm going to guess. I have a 50-50 chance. Well, but you have 20 questions. So if you think of how this grows, you have true, false for question 1, but then you'd have true, false for question 2, another true, false for question 3, kind of like when we did truth tables. Okay, but that's if you have 1 question, 2 questions, 3, but we have 20, so then it's going to keep branching off. True, false for all these. And then it's going to keep going, true, false, and it's going to go 20 times on all of these, right? That's huge. I don't really want to do that. I'm too lazy. But instead, I can think of it as choices. And again, I'm almost too lazy to do this too. So we'll kind of ... All right, that's what we do in math when we get lazy. ... Right? Okay, there's 20 questions, right? I'm not going to do all of them, but there's 20 questions. And okay, what are the choices? Well, there's 2 choices for question 1. Question 2 has 2 choices. Question 3 has 2 choices, and 2 choices, and 2 choices, and 2 choices, and 2 choices, ... 2 choices. And I have 2 choices 20 times because I have 20 questions that are true, false. So how many different ways or how many different answer keys could the teacher have? Well, it's going to be 2 to the 20th power. And again, repetition is allowed. Okay, I can have repeats like true, 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 true. So 2 to the 20th power is, oh my gosh, yeah. So again, sometimes students are like, I will just guess. It's just true, false. I think true, false is tricky. But do you get, oops, my calculator failed me there. There's the answer right there. All right, ignore that. I just hit some buttons. But yeah, I mean, 1,048,576 different answer keys that could be right. So it could be true, 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 false, 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 true, true, till the end. Or it could go true, false, true, false, true, false. So, I mean, this is the number of possibilities. And again, what is your probability of getting an A+, like guessing it right, would be 1 out of the total of this many chances. So, probably not a good idea, again, to guess. That is not good. Okay, now, what if order matters and things fall off? Like things that you can't have repetition, all right? So, let's think of an example, like say that order matters. So, say that I have 4 books, and I want to display 2 of them in, say, a window at Barnes & Noble. All right. Suddenly, order matters, and this is why, because maybe one book gets front and center right here, like in the window as you walk by. It's like, woo, wow. And then maybe the other book, maybe there's other stuff around here, but maybe the other book just gets that back corner, right? And if I'm an author, it's like, ooh, I want front and center. I don't really want that location, right? I want this one because that's what people are going to see, okay? So order matters here. Okay, so this is actually, if it's like a photograph where order matters, it's called a permutation. And notice we can't have repeats, so it's not like 4 choices, because once I choose one book, there's only going to be 3 choices left, okay? So there is a key on your calculator that does this. It is a permutation, and I have 4 choices. Order matters because I'm displaying them. So I have 4 choices, and I can go to math, and I can go to probability, and I can go down to what? This is a permutation, and I'm choosing 2 of my books, and I get an answer of 12, okay? If you have the cheaper calculator, let's see, 4 choose 2, what is that, 12? 12 different possibilities, permutations, 12 ways. On the other calculator, there would be a probability key on it, like the cheaper calculator. Let me pause, and I'll show you a picture of that. Give me a second. I'm going to pause.
You work more efficiently, which makes a complicated.
Okay, if you have this type of calculator, here's your probability key right here. So you would type in 4 probability and pick the P1 and then hit 2. And I'm going to show you on the Desmos as well. Give me a second. Okay, so if you're doing this on Desmos, all the funky stuff is under functions. And I have 4 books. I'm going to type in order. Order matters, so it's a permutation because the order in which I display them matters. And I'm going to pick, 2 at a time. And end of parentheses. Why doesn't it like it? Something's not right. Let me go back. NPR, choose 2. Why isn't it not liking it? Oh, okay, sorry. This one works differently. I hit NPR first, and then I do the total 4, 2. And then it gives me the answer of 12. All right, so that one works a little bit different. You type in the NPR first, and then 4, choose 2. All right, I'm going to get back to my other screen. All right, now, if you don't want to do that, you can do the multiplication principle, but things are going to drop off. And this only works because order matters, but I have only 2 slots. I don't have, like, here I had all 20 choices because I was answering all 20. Or here I had, let's see, on the previous one, I had all 5 questions because I was answering all 5. But notice here, I'm only picking 2 books. So I only have 2 slots, and I have 4 books. So I have 4 choices for this book. But you get once I pick it. So say I have A, B, C, D for books. If I pick B, then I only have 3 choices left for the next slot, and that's where that 12 comes from, okay? If I made a tree diagram for this one, which always works, sometimes it's a lot of work though, I have book A, B, C, D. Notice if you pick A, only B, C, and D are left. If you pick B, only A, C, and D are left for the next choice. If C is picked, book A, but I can't have, C because I already picked it, so B and D. And if D is booked, A, B, and C. And so you can see I have 3 times 4 is 12. That's where that comes from. But that's called a permutation. All right. If you have, and again, this is when you can't have repeats. If you have repeats, you have to do multiplication like the slots. There is no option. Now, say I have 6, let's go back to 4 books. Say I have 4 books. Say I just want to buy 2 of them. Okay, I just want to go to Barnes & Noble and I just want to purchase 2 books. Okay, then order doesn't matter because I'm not really displaying them. I'm just buying them. And think of like your sack. Okay, if they put book, put book A on top of book B versus book B on top of A, I don't really care the order in which they shove them in the bag. So basically, I just want to count how many different ways I can buy 2. Okay, if order does not matter, we call this a combination, all right? And this is the C thing on your calculator. So C, 4, choose 2. So on my calculator, I would do 4, probability. Where's my stat key? Nope, not stat, probability. Where am I at here? All right, I got to go to 4. Okay, I got to go to math and then go to probability. And I want the, come on, Julie, math, probability. I want the C1, 4C, and I'm choosing 2. Notice I only get an answer of 6. Okay, so this time it does 6. Okay, again, I could do that on Desmos, so let me go there. Okay, so on Desmos, I'm going to go to functions. This is a combination because order does not matter, and I have, 4 books, comma, and I'm choosing 2. So again, a little bit different order, but notice it also gives me 6. Okay, so if you absolutely hate that, let's think of a tree diagram. All right, so I just want to buy 2 of them, so I don't matter the order here. So if I have A, B, C, D, if I buy A, okay, and if you want to do this, you can always do this and cross things off, like A, B, C, D, right? But you're not going to buy A, right? You don't want 2 of the same book, so that would be 3 ways, okay? How about if you buy B, A, B, C, D? Well, okay, if you buy B, you don't want to buy B again. But notice you've already counted AB. So you don't even want to buy BA because that's counted when you buy AB. So, we don't want to get rid of, we don't want that guy. And then let's see, BC, BD, I think we're okay there. All right, let's look at C. I'm just going to rewrite them. We'll cross them off as we go. CC obviously would be buying the same book. We've already bought A with C. That's the same as C with A, so we don't want to do that. And we already did, so let's see, CA's already been bought. CB we bought over here. BC, that's the same. All right, and then D, we've already, Okay, I edited a little bit, but D we've already done. So you can see there's 1, 2, 3, 4, 5, 6 different